Okay, so here's our definition of the derivative. F prime at x, limit as h goes to 0, function at x plus h minus function at x all over h. Okay, what's the function at x plus h? It would be square root x plus h plus 2 minus the function at x all over h. Okay, so when you get a question like that, direct substitution is going to give you 0 over 0. So what are you going to do? You're going to try to simplify. When you see radicals, try rationalizing the numerator in this case. Okay, and we get the limit as h approaches 0, and in the numerator we've got x plus h plus 2 subtract x plus 2 all over h bracket root x plus h plus 2 plus root x plus 2. Okay, so simplify the numerator. We've got a positive x and a negative x. We've got a positive 2 and we're subtracting a 2. And we're left with an h in the numerator. And the h in the numerator cancels the h in the denominator. And we can now evaluate this by direct substitution. What happens if h is 0? Well, I have root x plus 2 plus another root x plus 2, which just gives me 2 of those root x plus 2's. What is that function? That function is the derivative. So this function would give me the slope of the tangent line to this curve at any point. Okay, except that before we started, I guess we should have talked about the domain of our function. So let's do that here. What's the domain for f at x? Okay, well, it's a root function, so whatever is under the root, that is x plus 2, has to be bigger than equal to 0, or x bigger than equal to negative 2. So in interval notation, this goes from negative 2, x is bigger, to infinity, the domain of the function. What's the domain for the derivative? Okay, it looks kind of the same, doesn't it? I can't have a 0 underneath a root, so negative 2 to infinity. But actually, can it be negative 2? Because I have another restriction with a rational function. I can't have a 0 in my denominator. So the domain for the derivative is round bracket negative 2 to infinity.